Alright guys, today we're going to be talking about polynomials, factoring, and solving by factoring. Some of this should be, or actually really most of these should be review as far as factoring goes, but then there's a couple of new things, so just kind of be looking out for those. I'll make sure to highlight those. Also, I'm trying for the first time an Apple Pen, so I'm kind of learning here, so sorry if I'm fumbling around in advance. So, first section here, we are going to solve by factoring using the greatest common factor. So what we're going to do here on these is we take both of these, we figure out what do they have in common. They both are divisible by 4 and x. So we're going to undistribute 4x, and then we're going to write what's left over here. So if you have 8x squared divided by 4x, you'll get 2x. And then if you got 20x divided by 4x, that's going to be just regular 5, and the x's cancel out. And then the whole idea with factoring, I think we even talked about this a few units ago here, is if you have something times something else equals 0, either the first thing equals 0 or the second thing equals 0. All right, so then what does that mean in this context? Here's your two things that are being multiplied, so either 4x equals 0 or 2x plus 5 equals 0. Okay. And then from there, go and solve individually for x. Here you get x is 0. Here you're going to subtract 5, and then you're going to divide by 2. That's negative 5 over 2. And those are your two answers. Okay. Here's a trinomial. The way I factor these here, I call it divide and slide. Some teachers will do factor by grouping with these, so depending on your teacher, you'll see different things here. But I do this little technique, I call it divide and slide. So here's what you do. You take these two numbers, you multiply them together. That will be, I guess, negative 40 right there. So I'm going to figure out two numbers that multiply to negative 40 and then add up to this negative 3 here in the middle. So if we go and do that, I think we're going to get something like, let's see here. I guess we could do, 4 and 10 wouldn't work out. Maybe 5 and 8. Yep, there we are. So 8 and 5, or 5 and 8, and it should be negative 8 because it's got to add up to this negative 3 here in the middle. Okay, the next step here, I write x minus 8, and then x plus 5. And then here's where the divide and slide come through. You divide by your a coefficient, whatever that is, divide by 2. You reduce the fraction as much as you can, if possible. This first one reduces to 4 over 1, so we'll just write as x minus 4. And then if it doesn't reduce, you bring this number right here in the denominator out to the front. And that would be 2x plus 5. Then from here, you set these equal to 0, and then you solve them out individually. Kind of like the last one here, so it looks like this first one, we're going to get x equals 4. And then the second one, you're going to subtract, and then you're going to divide, and look at that, you get 5 over 2 again. Those are those two answers. Okay. Now you have certain trinomials here that you can factor, and these are called perfect square trinomials. And notice here, you got a perfect square there, you got a perfect square there, and then if you do half of the perfect square times 2, that should be that middle term. When this happens, these factors, when you factor it, are both going to be the same thing. So most of the times we're going to skip to this right here. We're going to call this x plus 4 squared right there. And then sometimes you'll see in some math textbooks, they'll write this out here. They'll say this thing a squared plus 2 times ab, and then plus b squared factors to a plus b squared, kind of like this right here. So it's kind of like, I guess, a shortcut here. Really, I factor it like normal. I do divide and slide because you can still do that same technique for these. But that's a perfect square trinomial. And I guess I need to set these equal to 0. Really, it's just x plus 4 equals 0 twice. So x is going to be negative 4. And if you want to write it out twice, you can. Since it comes out to the same thing, we say this only has one solution. So this has the one solution of x equals negative 4. Okay. Alright, so difference of two squares, we've seen these here for a while. Here's your generic form. If you have something in the form of a squared minus b squared, those are both perfect squares. And we factor it this way. We say a times a gets us a squared, and negative b and then positive b get us b squared. And that's how these factor typically. So in this case here, what times what gets us 9x squared? We can say 3x and 3x at the front of our binomials. Okay, and then you'll have negative 1 times positive 1 will get you the negative 1 right there. And then I guess set them equal to 0, and then split and solve up individually. And for this first one, you get positive 1/3. For the second one, you get negative 1/3 as well. Or, well, just a negative version of 1/3. Okay, so there you go. Now, these next two here are the new ones. So you'll probably have not seen these. All right, and you have the sum of two cubes and then the difference of two cubes. So I guess what you need to figure out here is, in this case here, what's the cube root of 8x cubed? This will be the shortcut here. So if you know the cube root of that number and then you know the cube root of the other number, you say, okay, that's 2x and then this is 3. So that means with this case here, our a and our b are going to be the 2x and 3. And here's how you write it. So you write this is 2x plus 3. That's what your formula says here. If you want to write that this first thing here was a and the second thing was b, you can. And then the next thing you're going to do the 2x squared. So 2x squared is going to be 2x times 2x or 4x squared. You're going to do minus a and b, so minus 2x times 3. And then the last thing I think is b squared, plus b squared. And then that would be plus 3 squared, which is going to be 9. And typically we'll want to clean this up. 4x squared minus 6x and then plus 9. Now, a lot of people are going to say, hey, doesn't the leftover stuff right here factor? If you try to find two binomials that multiply to that, you're going to be looking for a long time because that is not actually factorable. That's all you can do as far as factoring. Okay, so there you go. That is that there. Now, there's another method. I'll probably show you all in a different example. Another method that you can do, I use synthetic division to do these types of problems because I don't like memorizing things. I'm kind of lazy that way, so I don't like memorizing this formula. So I'll show you an easy way you can do it with synthetic division. It really doesn't even take that much time, honestly. So I'll show you that here in a minute. Difference of cubes is pretty much the same thing. The only thing that's different here is your signs are a little bit different. So if you look there, you can kind of see that. So let's see how this one works out here. First of all, I need to figure out what a and b are. A is the cube root of 64x cubed. Hopefully they give you perfect cubes right there. Usually they are. The cube of 64 is 4. The cube of x cubed is 4x. B is going to be the cube root of apparently negative 1, which is going to get us negative 1. All right, and then the factoring formula says take your a, put that 4x, put your b, negative 1. So it should be the same sign there. And then notice here how with the difference of cubes, you put two positives right here. So the rest of this stuff will be positives. So we'll go 4x squared, or 4x times 4x, which is going to get us 16x squared actually. We're going to have a times b, and we put a positive version of that. So 4x times 1. It's just going to be 4x. And I know I put b here as a negative 1, but I think you disregard the sign. Okay. And then what else we got? We got b squared, so that'd be 1 squared. That's going to be 1 right there at the end. And that is how you factor. Okay, so those are the new ones. Once again, I'll show you with synthetic division here in just a moment on how to do those types of problems. It'll make it a little bit easier. So. All right, last thing here is called factor by grouping. You actually learn this in Algebra 1. And here's the idea with this here. If you have 4 terms, what you're going to do is group 2 of them together. So you got 2 sets of 2. You're going to go greatest common factor of the first group and greatest common factor of the second group. Okay, the greatest common factor of the first group is x squared. They're both divisible by x squared. If I go divide them both by x squared, you're going to get x and then 2. You're undistributing, essentially. Now we're going to do that the same exact thing here with the second group. I'm going to undistribute 5, and then I'm going to put the leftover stuff. This will be x plus 2, just like that. Okay, from here, and actually I need a plus there in between. From here, since both of these right here, this is one term, x squared plus x plus 2, that's one term, and then this is a separate term. Since both of those have an x plus 2 in common, I'm going to undistribute x plus 2. So we'll write x plus 2. And then the leftover stuff here, x squared and positive 5, are going to go back together into a group right there. And that is how you do factor by grouping. If you were to FOIL this back out, you get back up to this answer right here. Okay. And then from there, I guess you would set these equal to 0. So we'll go x plus 2 equals 0. And then the other one is x squared plus 5 equals 0. And actually, we'll kind of get a little bit more into the solutions here, I guess, on the next page. But I guess, yeah, we'll finish it out here. Notice there, if you square root both sides, that's going to be a negative. And we're going to get back into I stuff this unit here. So we're going to say that's the I root 5 right there. And that's x, and then you need plus or minus right there since you square rooted both sides. As far as the sum and difference of cubes, I'll talk about how to solve those here in a minute. I guess they had them equal to 0, but that's how you're going to do your solutions there on that one. So let's factor using any of the techniques that we learned. So the big thing on this is recognition. So with this one here, this is a sum of perfect cubes. You can use that formula that we just learned here above. But honestly, I'm going to show you a slightly easier way to do this, in my opinion here. So if you have this right here, I'm going to say, okay, a is x, and then the cube root of 125, b is going to be positive 1 right there. Or I'm sorry, 5 right there. Thinking of the coefficient. So anyways, we know that x plus 5 is eventually going to be part of this factor. Now let's say you get to a test and you're like, oh my goodness, I can't remember where the signs go. I can't remember, if it's a cubed here or a squared. And you can't remember. What we're going to do is off to the side, I'm going to use synthetic division using this factor of x plus 5. And remember, with synthetic division, you change the sign. And then I'm going to use this stuff. I'm going to use synthetic division. I'm going to divide by the x plus 5 factor, or the negative 5, as a solution. And then I'm going to see what I'm left over with, and I'm just going to put the rest in the parentheses. So here's what I mean here. So we're going to put a 1 here for the a. Since you don't have an x squared or a regular x, I'm going to put 0, 0, and then the 125 here at the end. Okay, and then here's what you do afterwards. Drop down your 1, multiply, add, multiply, add. Sorry, I was looking at that there. What did I do here? Oh, I know what. I had a positive, you should have had positive 25 when I multiplied. All right, and then multiply, negative 125, and then the remainder is 0. If the remainder is 0, this was a factor. That means the leftover stuff needs to equal this right here. So remember, you decrease the power by 1, that'll be x squared minus 5x, and then plus 25. And then that way I didn't have to remember anything about signs or what goes where. To me, that's a little bit easier if I have less stuff to memorize. So that's one way you can do it. Now, if you want to go and say, oh, okay, the a, if you want to memorize it, oh, that's x squared, b, that's squared, multiply them together, put a minus sign in between. You can do that as well. But if you're not confident on the signs, that's another way around it. And that's, honestly, the synthetic division, that's how you get to the answer. That's how someone figured that pattern out in the first place. So there you go. Okay, next one here, 4 terms. If you got 4 terms, this is probably grouping. Okay, factor by, or solve by, or actually we're not even solving here, we're just factoring here. So we'll do that. Here, let's change colors so we're not next to each other. So look here, you got r squared and r cubed, so they both have at least r squared. So we'll say this leftover stuff will be r minus 3. Notice with your second group, you can pull out a positive 6, so that'd be r minus 3 as well. These have to be the same exact thing to do the next step, which is undistribute those. If you undistribute r minus 3, you're going to be left with r squared plus 6. And then that is it right there. This is factored. If you were solving, you would set those equal to 0 and then finish solving from there. Okay. Next one here. All right, special one here. I have some kids say, well, x to the 4th power. We hadn't seen anything like that. This x to the 4th can still be written as a perfect square. X to the 4th, if we did the square root of x to the 4th, that's x squared. So with this one here, just think about what multiplies to x to the 4th. You can say x squared and x squared. All right, and think about what times what gets us negative 36. We can say negative 6 and positive 6. Okay. Now, sometimes if this was a perfect square, we could do a difference of squares. Notice that negative 6, you can't, that's not a perfect square, so this is all you can do. But sometimes, like if this, for whatever reason, was a 4 right here, if that was a 4, you'd be able to break that down another step. I can't remember, we might get to one where we see something like that. In fact, yes, I already see it here that we're going to do. So we'll get to it here in a minute. All right, look at that. You got a trinomial. Kind of a similar idea. You got a d to the 4th out here in front. So what you're going to do for this here is figure out what times what gets us d to the 4th. We can say d squared and d squared. What times what multiplies the 10 and then adds the negative 7 right there. So we'll do 5, negative 5 and positive 2. And then that's all you can do there in that case. Now example E, this is kind of what I was talking about here. With this one, it's a difference of squares. Notice got a minus sign. Notice 81 is a perfect square. Notice C is a perfect square. So then we're going to go C squared and C squared. And then you're going to go negative 9 and positive 9. Now this right here, you can't factor C squared plus 9. There's nothing else you can do for this one. But C squared minus 9, we can actually simplify that and factor that one out. And that would be C minus 3. And then C plus 3. Notice that's another difference of squares. It's a difference of squares inside of another difference of squares, I guess. So this would be this one fully factored. And I'd definitely put a star next to that one because that's, you'll see that quite a bit, where they'll have you do a couple of extra steps for factoring. Okay, you got another with 4 terms. Anytime we see 4 terms, hopefully that is screaming out at you to do grouping. We got x squared when we factor that out. Both of these are divisible by x squared. If you divide x cubed by x squared, you get x. If you divide 6x squared by x squared, you get just 6. Okay, it looks like the second group you can pull out a positive 7. So that would be x and then plus 6. Notice that both of your groups are the same. You get to undistribute those. And then we write this as x plus 6. And then the leftover stuff is x squared plus 7. And then that is it. All right, last page, I believe, here with this one. So this one's kind of a special one as well here. It looks like it could be a difference, or actually a sum of cubes here. But notice you got the 2 and the 54. Those are not cubes. But here's the deal. We can actually undistribute 2 from the very beginning of this problem. So if we undistribute 2, we're going to get w squared and then plus 27. Okay, and then if you remember your little rule, you can now do that right there. You can undo the 2. So undo the w squared plus 27. Just keep in mind the 2 that you factored out better be at the very end of the question. So if you want to use a little pattern or the synthetic division, you can do either way. Oh, something's wrong here. I wrote squared, and that should have been cubed. So the cube root of w cubed is just w. The cube root of 27 is 3. And then I guess we're going to write this as w plus 3 for the first one. And then the second, the leftover stuff, that's going to be w squared, 3w, and then actually it should be a minus 3w. It's the opposite sign on that first one. And then 3 squared is just going to be 9, I guess. All right, and then since you had the 2 to begin with, we finish out with the 2 right there. Excellent. Okay, this one here looks like, this one's going to be kind of hard here because they're not all divisible by the same thing. So I guess we're going to have to kind of figure out with this one here, do divide and slide, I guess, figure out what multiplies a negative 24 and then adds up to, I guess, negative 5 here in the middle. And I guess we could go negative 8 and 3. So we're going to write this as y and then minus 8 and then y plus 3. Now, it's actually not y and y here because it's got to multiply to y to the 6. So I'm going to go y cubed and then y cubed right there. Okay. Next, after this, we need to go and divide. We divide by our a coefficient, which is 6. Now, some of these reduce, but not all the way. This first one is going to reduce to 4 over 3. The second one here is going to be y cubed, and then this will be 1/2. And then this is where you do your slide steps. Slide those up here to the front. This will be 3y cubed minus 4. And then this will be, 2. And then y cubed plus 1. And that is it. Okay, you can try doing something with 3w cubed minus 4. I don't think that actually factors anymore, so that's how we leave our answer. Alright, 4 terms. Got another grouping problem here. I like this one because it's got the negative. So we will factor out, in this case, both of those are divisible by 9, and not just 9, 9m squared. If we divide by 9m squared, that'll be m plus 2. The second group here, now if you only pull out a 4, you're going to be left with negative m minus 2, which doesn't get you anywhere. So actually with this one here, we need to make sure we pull out the negative with it. Factor out negative 4, and then that'll be m plus 2 right there. Okay, and then now take this stuff, factor it out. That's m plus 2. And then the second thing is 9m squared minus 4. And actually here with this, 9m squared minus 4, that's a perfect square, that's a perfect square. This is the difference of squares. So this actually simplifies even further. This will be 3m times 3m gets you 9m squared. And then negative 2 and positive 2 are going to get you the negative 4. And just drop down that m plus 2 here at the end, and then you're good to go. So, yeah, that's kind of a tricky one right there, so be kind of careful. Okay. All right, last section here is doing everything that we just did. We're going to factor, but then we're going to set our factors equal to 0, actually kind of like how the lesson started. So, let's see what's going on here for this one. So you got 2 terms in this case. I think the factor technique we're going to use is greatest common factor. These are both divisible by n cubed. And if we divide, we'll get n and then plus 6 left over. Okay, then from here, set your factors equal to 0. N cubed equals 0. So it's asking what times what gets us 0. The only thing that would work is 0. And also we got n plus 6 equals 0. So this will be n equals negative 6. Those are your 2 solutions right there. As far as how many you're going to say we have 2, and then they are both real. So 2 real solutions. Now this next one here, it's kind of getting exciting here. This one's got everything is actually divisible by not just r, but everything is divisible by 3 as well. So we're going to factor out 3r. And then we're going to write r to the 4th. We got 5r squared. And then minus, I guess, was that 6? Okay, and then now I need to figure out some factors that multiply to negative 6 and add up to positive 5. That'd be positive 6 and negative 1. As far as what times what gets us r to the 4th, we can go r squared and r squared. Okay, and then you got 3r out here in front. Now from here, you can set each factor here equal to 0. You can go 3r equals 0, r squared plus 6 equals 0, and then r squared minus 1 equals 0. The first one here is pretty straightforward. Divide by 3, you're going to get r is equal to 0. Actually, I'm going to skip to the last one here. Last one, you got r squared is equal to 1. If you square root both sides, not only do you get 1, you get positive or negative 1. Remember, when you square root both sides, got to have a plus or minus. Now this last one here is going to be kind of weird because when we subtract over 6 and then square root both sides, that's actually going to get us an imaginary solution. We're going to get imaginary and then, or I, and then square root of 6 right there, and that's for R. And also one other thing here, let's see if this will let me. Okay, yeah, there we go. One other thing here is if you square root both sides, you need a positive and a negative there. So this one had 1, 2, 3, 4, 5 solutions right there. So this one had 3 real and then 2 imaginary solutions. Okay, and another property that we're going to eventually get into here is the highest power or the degree of the polynomial will tell you how many solutions you have. So if you have degree 5 here, you better have 5 total solutions. We kind of get into that a little bit later more so. But anyways, all right, this next one here, it looks like you got 4 terms, so we're going to solve by grouping, but remember with factoring you need these all equal to 0. So I'm going to move over this 18W and then move over the 90, so minus 90 as well. Okay, from here I would figure out what these first 2 things the first group has in common, and then the second group, what do those have in common? First group, it looks like you can pull out a 6W squared at least. Divide both of those by 6W squared, and that gets you W. And then it looks like plus 5 right there. All right, the second group, I guess you can also pull out some stuff. Looks like a negative 18. And then I believe you're going to get W plus 5 as well in that case. And then since you have W plus 5 in both of those right there, you get to undistribute W plus 5. If you take those away, what's left over? It's 6W squared and the minus 18. And then you can set these individually equal to 0. W plus 5 is equal to 0. 6W squared minus 18 equals to 0. I guess we could have factored out a 3 at the beginning of this here, or actually even a 6, but we're good on that. It's not going to change anything here at the end. So I guess that first one you get negative 5. Now the second one here, you move over the 18 first. Here, actually, I should probably write that as my second step. Really, we need to say 6. No, that was my first step. I don't know what I'm doing here. Let's move that back up here. All right, and then that was W squared. Divide both sides by 6, and then I guess that gets you a 3. And then we'll square root both sides, and that'll get us plus or minus the square root of 3. And that is it right there. So that gives us 1, 2, and 3 real solutions. Be careful, just because you see a square root doesn't mean it's imaginary. If you have an I with it, that's what makes it imaginary. Alright, and then this last one here, I believe this is the last question here for today. This one here is a difference of perfect cubes here. And this one does get a little exciting here at the end, so just kind of bear with me on this one here. So as far as what's A and what's B, to use our little trick, A in this case is X. That means B is going to be the cube root of 512. I think that's 8. So we'll say 8 right there. All right, and then the way you write this, the first one is A minus B. So we're going to go X minus 8. Notice that's got to be the same sign. All right, your second factor is X squared. A times B, so plus 8X, and it's plus A times B, and then it's going to be plus this last number, which is going to be 64. All right. Now, since we can't factor this right-hand side anymore, we're going to have to use a different technique as far as figuring out the solutions for those. So this first thing here we can say is equal to 8. I guess technically we can write out this right here, x squared plus 8x plus 64 equals 0. And you can try for a while. You can try factoring, but you're not going to be able to factor the rest of that. So here's what we're going to do for this. We're going to use the quadratic formula to find the solutions for the rest of this right here. And I think there's one just like this on the homework here. In the quadratic formula, if you forgot, it's negative b plus or minus square root b squared minus 4ac all divided by 2 times a. Okay, so we're going to go ahead and take all of our values. Negative 8 plus or minus square root 8 squared. Make sure you put the parentheses, especially if you got negatives. 4 times a times c. And then all over 2 times a, or in this case 2 times 1. Alright, so this is negative 8 plus or minus 8 squared should be 64. And then 4 times 64. Let me grab a calculator here. I think that's 256. 4 times 64. Yep, 256. So minus 256. And then divided by 2. This will be negative 8. This will be the square root of negative 192. Okay. After that, we can actually simplify our radical down here. So let me do that. 192, I guess if you don't know where to start, it's divisible by 2. So you can go 2 and 96. Divide that by 2, that'd be 2 and 48. Guess if we keep the train going here, we can go 224, 212, 26, and then last but not least, 2, 3. So you got it 1, 2, 3 pairs of 2. So that's going to be 2 times 2 times 2 outside of the radical. That'll be 8. Leftover thing stays inside. That's going to be 3. Since there was a negative, I'm going to put not only 8, I'm going to put 8i. Then you still need plus or minus. And then the last thing here is, since everything here is divisible by 2, write that as negative 4 plus or minus 4i square root of 3. And that is 2 of your solutions, and then way back up here, that was your other solution. So this has 1 real and 2 imaginary, since you had the I. And you'll be expected to do that once or twice on this test here and get those imaginary solutions just like that. So be ready to go for those there. But otherwise, that is it for today.